Imagine this. It's 1981. You're a kid. You're glued to your TV, watching cartoons, when suddenly an announcement comes on. NASA is, for the first time ever, launching their first fully reusable spaceship, and it's being aired live. This new ship, named the Space Shuttle, looks nothing like the ones from the Apollo program you learnt about in school. No, it looks much more modern, like a big passenger plane, and you can't wait to see it in action. You wait for the launch, biting your nails and lips because you're about to witness what every kid dreams of: a trip to outer space. And as soon as you see those engines light up, you're hooked for life. That's the effect the Space Shuttle had on 30 years worth of youth. The first true leap into the final frontier. And yet, 30 years of development, 30 years of hype, only for it to fall into obsolescence and be retired in 2011. Why did it fail? Could it have been modernized? And what was the point of it, anyway? Well, today, we'll be explaining all of the questions you ever had about the Space Shuttle, and you'll finally hear the story of the spacecraft that got millions of kids into space. So let's begin. When NASA unveiled the Space Shuttle in the 1970s, it was nothing short of revolutionary. Unlike the disposable rockets of the Apollo era, the shuttle promised reusability. A spacecraft that could launch, return to Earth, and fly again. It was designed to reduce costs, democratize access to space, and enable missions ranging from satellite deployment to scientific research in orbit. The shuttle was a symbol of ambition, blending cutting-edge technology with bold vision. Its reusability was a game changer. Engineers envisioned a fleet of shuttles capable of launching weekly, practically creating an assembly line to the stars. It was a promise of efficiency, accessibility, and a future where space exploration became not just a possibility, but a routine as commercial aviation. The Space Shuttle program achieved remarkable milestones. It launched satellites, serviced the Hubble Space Telescope, and helped construct the International Space Station. Astronauts conducted groundbreaking experiments in microgravity, pushing the boundaries of science and engineering. For decades, the shuttle was a source of national pride and a symbol of humanity's aspirations. However, the program was not without its shadows. The tragic losses of Challenger in 1986 and Columbia in 2003 served as a stark reminder of the risks inherited in space exploration. Both disasters claimed the lives of 7 astronauts, shaking public confidence and prompting deep scrutiny of the shuttle's design and operations. Investigations revealed systematic issues, technical flaws, organizational lapses, and an underestimation of risks. These tragedies forced NASA to confront the limitations of the shuttle and its long-term viability. Now, while the Space Shuttle was a technological marvel, it was far from the cost-effective solution NASA had envisioned. The program's reusability came with hidden expenses. Despite it being technically reusable, each shuttle required extensive refurbishment after every flight, including the replacement of thermal tiles and the inspection of components. As a result, launch costs soared to approximately $450 million per mission, far exceeding initial projection. These economic realities clashed with NASA's growing ambitions. As an agency that looked to the moon, Mars, and even beyond, it became clear that the shuttle's high operating costs were unsustainable. The program, which was once a symbol of affordability and accessibility, had become a financial anchor, limiting NASA's ability to pursue deeper space exploration. As a result, in 2004, President George W. Bush announced the vision for space exploration, a roadmap to return humans to the moon and eventually Mars. This vision called for the shuttle's retirement by 2010, which was later extended to 2011. The decision was pragmatic. The shuttle's design, rooted in 1970s technology, was ill-suited for the challenges of interplanetary travel. NASA needed a new generation of spacecraft designed from the ground up for exploration beyond low Earth orbit. The final shuttle mission, STS-135, marked the end of an era. On July 8, 2011, for the final time ever, Atlantis lifted off from Kennedy Space Center carrying supplies to the ISS and closing a chapter in space history. As the shuttle touched down for the last time on July 21, 2011, it left behind a legacy of triumph, tragedy, and transformation. Could the shuttles be revived? Well, technically, yes. Practically, no. The shuttles were retired not because they couldn't fly, but because they no longer fit the future NASA envisioned. First of all were safety concerns. The Challenger and Columbia disasters exposed fundamental risks in the shuttle's design, including the reliance on solid rocket boosters and the vulnerability of its thermal protection system. Addressing these issues would require extensive redesigns, which effectively creates a completely new vehicle. Second of all is economic viability. The shuttle's high operating costs made it an unsustainable platform for NASA's evolving priorities. Modern spacecraft such as SpaceX's Dragon and Boeing Starliner offer lower costs and greater efficiency, enabling more frequent missions. Third of all is technological obsolescence. The shuttles were, by all accounts, a product of their own time, incorporating technology from the 1970s and 1980s. Reviving them would mean investing in outdated systems rather than advancing the state of the art. NASA's Artemis program, for instance, relies on the Space Launch System, which is a new rocket designed for deep space explorations. And the fourth reason is strategic focus. NASA's goals have shifted towards sustainable exploration of the Moon and Mars, and the resources required to maintain the shuttle program would detract from these objectives. Furthermore, the Space Shuttle itself wouldn't be a viable vehicle for these kinds of missions. Therefore, by embracing partnerships with private companies, NASA can focus on its core mission or pushing the boundaries of human exploration, and because of this, the shuttle simply does not have a future in NASA's usage. Now, though the shuttles no longer fly, their legacy endures. Despite not being directly useful as much as NASA wanted them, the program paved the way for modern space exploration, inspiring a new generation of engineers, scientists, and dreamers, just like you and me. Technologies developed from the shuttle, from advanced materials to life support systems, and they continue to influence aerospace design. The ISS, a cornerstone of the international collaboration, owes its existence in part to the shuttle's assembly missions. Moreover, the lesson learned from the shuttle program have shaped the future of space exploration. NASA's current approach emphasizes safety, sustainability, and cost effectiveness, building on the hard-earned wisdom of the shuttle era. Private companies like SpaceX and Blue Origin have also drawn inspiration from the shuttle's achievements and challenges, driving innovation in reusable rocket technology, with SpaceX being the most prominent driving force today. Now, the Space Shuttle wasn't just a spacecraft, it was a catalyst for the technological advancement with applications far beyond space exploration. The thermal protection system developed for the shuttle has practically inspired the design of modern heat-resistant materials used in various industry branches, ranging from aviation to energy production. Its engines, particularly the RS-25, set a benchmark for efficiency and reliability, influencing propulsion systems worldwide. In education and popular culture, the shuttle program ignited curiosity about science and space. Generations of students were inspired to pursue careers in the STEM fields, while the image of the shuttle launching into the heavens became a cultural icon. Films, books, and documentaries immortalized its mission, ensuring that its story continues to resonate. The shuttle also played a pivotal role in fostering international partnerships. Programs like the ISS brought together nations that once competed in the space race and in geopolitics, showcasing the power of collaboration over rivalry. The shuttle ferried astronauts from around the world, symbolizing unity in the shared quest to explore the unknown. This spirit of cooperation has laid the groundwork for future joint missions, from lunar bases to Martian exploration. As a result of all this, the Space Shuttle program serves as both a cautionary tale and a source of inspiration at the same time. It highlights the importance of balancing ambition with pragmatism, of prioritizing safety without stifling innovation. The program's triumph and challenges offer invaluable lessons for designing and managing complex projects, not just in aerospace, but across all fields of engineering and space. And today, as humanity stands on a cusp of a new era in space exploration, the shuttle's legacy is a reminder of what is possible when vision meets determination. The Artemis program, aiming to return humans to the moon and establish a sustainable presence, owes much to the groundwork laid by the shuttle. Similarly, the burgeoning commercial space industry builds on the technology, logistical frameworks, and the philosophy established during the shuttle era. And as we look into the future, the space shuttle remains a poignant reminder of what humanity can achieve when ambition meets ingenuity. Its retirement, while seeming like an end at the time, wasn't that. It was a transition, a stepping stone towards the next great leap. And while it didn't directly do anything meaningful, it did serve as the basis that was just as important as the Apollo program for the future of space exploration. In every possible sense, the Space Shuttle is more than just a vehicle. It is a testament to the human spirit, a bold declaration that we are not bound by the confidence of our planet. As we chart a course to the moon, Mars, and beyond, the lessons of the shuttle era will guide us, ensuring that the pursuit of the unknown remains an enduring cornerstone of human endeavor.